Hello, my name is Tsula, and this is Chapter 2 of my multi-part series, Tsula's Complete Video Guide to Becoming an Amateur Astronomer. In Chapter 1, I introduced myself and I explained how I became an amateur astronomer. And this is Chapter 2, Getting Started. No, that's not how we're going to get started. If that's what you were thinking, just toss that out of your mind because you're light years away from that. No, in this chapter, we're going to be assessing your living situation. Yes, your living situation, because amateur astronomy is an outdoor nature hobby. That means you have to go outdoors. So we need to see what your outdoor situation is like, either from your house or your apartment, because in order to get started, you have to be able to see the sky. So we need to know if there are blockages. Can you see the sky? Do you live in an apartment? Do you have to go down an elevator? Do you have stairs? That might influence your decisions later on equipment. But at the beginning, you just need to be able to see the sky. Now, most people live in the suburbs or urban areas, and there's going to be some light pollution. And yes, it's better in a dark sky, but you have to be able to see the sky at all in order to be an amateur astronomer. So we need to see what your situation is and see if it's no good, meaning there are trees or lights or houses and you can't see the sky. Maybe you have to go to another location. And that means you have to make a certain level of commitment. I realize that amateur astronomy is just a hobby, and hobbies are supposed to be fun, but even hobbies involve a certain level of commitment. After all, if you join a book reading club, you have to read the books. Or if you join the football team, you have to go to practice. So if you want to be an amateur astronomer, you have to be willing to go outside, maybe be bitten by mosquitoes, maybe be hot, maybe be too cold, or maybe you have to travel to get somewhere where you can see the sky, and hopefully a dark place. So let's go outside and assess the situation. I have a scale, Tsula's scale, and on this scale it's better if you're 0 or 1. And if you're above 10, that's not good. So let's go outside and see where this place lands on Tsula's scale of suitable observation sites for amateur astronomy. Okay, to observe the sky from this location, I'd have to go down these stairs, and that means if I had a Dobsonian, for example, it might be a little tricky. So we're going to give this location 2 points for stairs, or if you're up on the 3rd level or in an apartment, you have to go down an elevator, give yourself 2 points. Okay, from here I would say more than 50% of the sky is blocked. That's not good. If more than 50% of the sky is blocked by trees or buildings, you're going to have to give yourself 2 points. Okay, another consideration is whether your neighbor has one of those annoying security lights pointed at your house that can't be blocked. If you can't block it, you're going to have to give yourself 1 point, because you could still see the sky potentially, but it's going to be very annoying. Another thing is, are there electrical wires going across your yard? If so, give yourself a point. Can you see Polaris? If you can't see Polaris, you're going to have to give yourself 2 points. And another consideration is, how accessible is your yard? Do you just walk out the door to it, or do you have to go to a common area, or do you have to walk some ways? If it's not right out the door, give yourself another point. Any deterrence to just walking out the door and looking at the sky, give yourself points. Do you live in a northern town where it gets below freezing? Give yourself a point, because there are going to be a lot of days where you probably don't want to go outside, unless you're like me and you're completely insane and you'll go out no matter what. Or do you live in the south where it's very humid and maybe it's too hot, or there's so much dew that your equipment gets condensation on it? Give yourself a point. Okay, those are a few things to consider, mostly accessibility, whether you can see it, are there obstructions. And if you step outside of where you live and it looks like this, well, you're probably going to have to travel to go somewhere in order to have a view of the night sky. And if it snows where you live, give yourself a point. No, give yourself 2 points. If your observation site is unsafe, give yourself 2 points. If you have to worry about wild animals in your observation site, which probably most of you don't, although you could have to worry about marauding raccoons, give yourself 1 point. Okay, for this next section, we're going to need a compass. You can use a compass like this, but if you're using a compass like this compass points towards magnetic north and not true north, which is okay. You can figure out the difference because for astronomy, we're concerned with true north. If you have a topo map lying around, you can consult the topo map. All topo maps have a little diagram of a compass, and they'll show you the difference for your location between true north and magnetic north. For this location, which is at the 45th parallel, the difference in 2013 when this map was published between true north and magnetic north was 12 degrees west. It continues to move 0.09 degrees west, so we'll add that, and as of 2022 it's about 19 degrees difference between magnetic north and true north. But if that's too complicated for you, there's an easier way to do it, and that is that your phone probably has a compass on it, and you can actually set your phone's compass to only point towards true north. So I've set mine to point towards true north, which is behind me. And also, nice feature of these compasses is it tells you your latitude and longitude, which you will need to know later for setting the go-to computerized German equatorial mount. But for now, what we want to do is find out if true north is blocked by a tree. So point your compass to true north, and you can see down there what your latitude is, and look up approximately that high from the horizon, just estimate. And I already know because I need to know where Polaris is. It's just above the top of that tree. But if Polaris is blocked by a tree where you are, give yourself 2 points. And we haven't even mentioned light pollution. If there's light pollution, give yourself a point. If you're over 10, then you're probably going to have to travel. And so that means you need to ask yourself before you go further, are you willing to travel? Because that's a big commitment. Once you get equipment like a telescope, you're going to have to put it in the car, and that's going to take some time. It's going to take some time to set it up. So the first things to ask yourself are, where do you fall on the scale? Are you over 10? Will you need to go to a separate location to observe? And what's your commitment level? Are you really willing to make that commitment? If you are, and you're still excited, and you should be, because the night sky is a fascinating thing to study, then we'll move on to the next thing. Before we continue, I should point out that I have been to the Southern Hemisphere twice. I've seen the Southern Cross. I can't remember much else. And I don't have any other personal knowledge about it aside from that. Therefore, this complete video guide will be only for the Northern Hemisphere. Sorry, mate. Guide is for observational amateur astronomy, and so if you're still with me, we'll move on to the next step, which is learning the night sky. If you lie on the ground like this and imagine that you're inside of a giant ball, and the ball is a circle and it's 360 degrees, so that everything below the ground is half of the circle, or 180 degrees, not visible to you. It's in the southern hemisphere. But if you look all the way south to the horizon and go as high above you as possible, the highest point, also known as the zenith, that's 90 degrees. And continuing from the zenith all the way north is another 90 degrees, so 180 degrees. But let's divide it into even smaller parts, because this is going to help us locate the stars and objects when it gets dark. If you extend your pinky is approximately 1 degree, so that if you went from the zenith to the horizon with 90 pinkies, that would be 90 degrees. If you hold up 3 fingers, that's approximately 5 degrees. If you extend your fist, that's 10 degrees. If you extend your pinky and your index finger, that's approximately 15 degrees. And if you extend your pinky and your thumb, that's approximately 25 degrees. So we're going to use those measurements to help us locate stars and objects when it gets dark. If you walk outside and you look up in the stars and it just looks like an impossible jumble, it can be broken down by finding the Big Dipper. Most people would recognize the Big Dipper. It's an asterism, which is just a pattern of stars. It's actually in a constellation called Ursa Major, the Big Bear. And there are 88 constellations as designated by the International Astronomical Union. And the Big Dipper is part of Ursa Major, and most people recognize it because it looks like a bucket or a plow or something like that. And just by some cosmological coincidence, the brightest stars of the Big Dipper happen to be those same measurements. Here's a diagram of the Big Dipper showing the approximate degrees between the brightest stars. And there are some other great things about the Big Dipper that are going to help us make sense of the night sky and figure out some of the other constellations. Learning the night sky is the one time that you do get to be the center of the universe. But of course, it's just a fiction to help us learn the night sky. We are, of course, hurtling through space. Earth spins on its own axis and takes 24 hours to make one revolution, and that's what gives us night and day. And we also rotate around the sun a little over 365 days to make one revolution around the sun. And just to learn the sky, we pretend that we're the center and that it's a giant ball around us. I just looked all over the house for a ball, and I guess I don't own a single ball. My ball throwing days are over. So this orange will have to do. Imagine that this orange is the Earth. This orange is not even round, but imagine that this orange is round and that it's the Earth. And that this pole is going straight through the middle of this orange Earth, and that represents the Earth's axis around which the Earth rotates. If you extend this pole through the Earth up into the ball that we said at the beginning we imagine surrounds us when we're the center of the universe, it will be pointing in the northern hemisphere to the North Celestial Pole. And the North Celestial Pole is the point upon which all the stars in the heaven revolve, including what we call the North Star here in the northern hemisphere, Polaris. Polaris is near the North Celestial Pole, but it's not exactly on it. Polaris also rotates around the North Celestial Pole. Polaris wasn't always the North Star. 3000 BC, the North Star was Thuban, also known as Alpha Draconis, because it's in Draco, the dragon. And in 13,000 years from now, the North Star will be Vega. But we don't have to worry about that. For now, the North Star is Polaris. It's the closest star to the North Celestial Pole. To find the Big Dipper, you need to look north, because the Big Dipper is an asterism that is known as circumpolar. It circles closely around the North Celestial Pole. And some people like to say that it's visible year-round, but I hate it when people say that because I can't see it behind those trees back there several months out of the year. But it does circle closely around the North Celestial Pole. And so to find the Big Dipper, look north. And then we're going to use the stars of the Big Dipper to find some other constellations to help us find our way around the night sky. Another thing that will help you in learning the night sky is to learn the stars and planets' apparent brightness. Not their actual brightness, but how they appear to us here on Earth. And they're assigned a number, and the lower the number, the brighter the object is. The brightest object in our sky is our sun at -27. And the next brightest is the full moon at -13. And then Venus, which goes through phases, similar to the moon, because it's so close to the sun. And at its brightest, it's -4.7. Jupiter also changes in magnitude, but at its brightest, it's -2.9. And the brightest star in the sky is here in the northern hemisphere, and that's Sirius, the dog star, found in Canis Major. And it is -1.4 magnitude. The North Star, Polaris, is magnitude 2. So when you're looking up, that helps a lot to know the magnitude of the stars, because you're going to have to find the brightest stars to help you to point to other things, and that's called star hopping. If these clouds move off, later I'll get my laser pointer out and jack up my ISO as high as I can and try to show you some things in the actual night sky. But for now, you should know that, as I said, the Big Dipper asterism is in the north part of the sky. And if you have a star chart, one of those circular planispheres, you make whatever direction it says at the bottom of the plane, that should be the direction you're facing. So if you're facing south, it should say south at the bottom. But looking north, you will find the Big Dipper, and in the spring it starts to climb higher and higher above Polaris, and the two, what they call pointer stars, at the top of the bowl of the Big Dipper make a line and point towards Polaris. If you make a line from those two stars in the other direction, they point to Leo, and the brightest star in Leo is Regulus. Another thing about the Big Dipper is, if you start at the last star in the handle of the Big Dipper, Alkaid, and you arc from there, the next brightest star is Arcturus. So you can remember that as arc to Arcturus. And then if you draw a straight line from Arcturus to the next bright star, that's Spica, speed to Spica. So arc to Arcturus and speed to Spica. Another constellation that you will start off with in learning all the constellations is Orion, which dominates the winter sky and also the beginning of spring, with its bright star Rigel, which is at the lower foot, I think, and Belt, which are all magnitude 2 stars. And then he has a sword And then there's a bright orangey star at the top, Betelgeuse, which is a variable star, sometimes not as bright. And it dominates the sky, and you can see it from suburban and even urban skies. And that will help you to find other things too, because once you find Orion, which is so obvious in the sky from almost anywhere, then you can find some other things. Just as I was explaining that there's an imaginary pole going through the center of the Earth pointing to the North Celestial Pole, and that all the stars in the heavens revolve around that pole. Also, the constellations change with the seasons, because not only is the Earth rotating on its own axis, but we're revolving around the sun. And as we revolve around the sun in our yearly movement, the seasons change and the constellations that we see change. So if you get up and you, in the night, to watch the stars, if you're out there long enough, you'll see the constellations facing south will rise in the east and appear to set in the west, and the ones in the north will appear to rise in the west and set in the east. And then, as the seasons go by, soon, for example, Orion will be setting. Goodbye, Orion, and hello, spring. Leo will start coming up, and it'll be galaxy season. There are a lot of galaxies in that area of the sky. And the reason that I said earlier that Polaris will not always be the North Star is because not only are we spinning on our own axis, but the Earth wobbles a little bit. And so the position of the stars changes imperceptibly and over time. Also, we know where to see the planets because the Earth and all the planets in our solar system move in an elliptical revolution around the sun, and that appears to us from Earth as a line in the sky that curves over the imaginary celestial equator, just like the axis can be projected to the sky to make the North Polar pole, North Celestial Pole. If we project the Earth's equator into the sky, there's a celestial equator. And the line, imaginary line, that the planets move along is called the ecliptic. And it goes under the equator and then over the equator. And that's where you'll always see the planets. When they are opposite the sun, the planets will appear in the night sky. And when they are not opposite the sun, they will appear in the morning sky. Right now, there is a dramatic lineup of planets in the morning sky. But I'm not a morning person, so I'm going to miss it. But soon there will be a dramatic conjunction. A conjunction is when the planets appear to be close to each other. On April the 5th, I probably won't produce this before April the 5th, but Mars and Saturn will be within 0.3 degrees of each other on the early morning hours of April the 5th, before sunrise, because of course when the sun comes up, it's going to wash everything out because it's so bright. But there are other conjunctions, and there will be some more later in April. So that's just some basic information to get you started on your journey to becoming an amateur astronomer. And to get started, you should start with your naked eye. That's all you need, and that's how you should start. Go outside, and even if there's light pollution or the moon is blocking out a lot of things, or you should look at the moon, you can see a lot from urban and suburban skies, and you should start with your naked eye, trying to pick out the brightest stars and learning the constellations. And there are many aids to assist you. There are simple things like this planisphere, and mine is warped because it got too close to the campfire. But these are nice because they just point out the brightest stars, and they might be the only ones you can see from your particular observation site. And there are other star charts. If you subscribe to Sky and Telescope, they provide a star chart in every issue. And there are some books. One of them I would recommend is Terence Dickinson's Night Watch. This is a very old version that somebody gave me years ago when I got my first telescope. And of course there are many apps that you can use, such as Sky Safari Pro or Stellarium. I think you have to pay for those, and I'm not a big fan of those because you want to get your eyes dark adapted when you go out so you can see the sky, and when you pull out your phone it ruins your night vision. So they're nice because you can have them on your phone and you can move around the sky with them, but they're not my favorite. I mean, I have to use them sometimes, but if you're starting out, I'd just go out with a star chart. One thing you will need though, and they're pretty cheap, you can get an Energizer one from the hardware store, but make sure that it has a red light on it, because you need a red light to maintain your dark adaptive vision. And don't get one that makes you scroll through white to get to red. You want one that starts off red and stays there, because the minute it turns white, it's going to blind you again. And there's some other books and resources to help you. But the main thing is experience. You have to get out there under the night sky and look up, and then things will start to come together. All of the constellations have their brightest stars assigned a Greek alphabet letter that was by a man named Johann Bayer, who published his catalog in 1604, and he designated the brightest star of each constellation with the Greek alphabet, starting with Alpha. And here is a copy of the Greek alphabet if you're interested in that. Some of the stars, or a lot of the stars, have names, and they're mostly Arabic words because the Arabs were the first to make advancements in astronomy, and some of them are also Greek or from Greek or Roman mythology. But that will help you to know the brightest stars, and then learn the constellations, and then learn some of the tricks for star hopping. Finding a bright star and then going from that to another bright star, and then from that going to an object that you want to locate. And that's how you start off in amateur astronomy. No, you should not go out and buy a telescope, not by any means. So many people go out and buy fancy equipment and it ends up in a closet collecting dust because they didn't start with the basics. And also you need to go through my numbering scale to see what your observation site is like and what your commitment level is. And also you need to learn the night sky and learn the constellations and the stars. And then after you start off with the unaided eye, I would recommend you get a pair of binoculars. You may already own a pair. This is a pair of expensive 10 by 42s, but you don't need to get an expensive pair. I use these for birding because that's another hobby that I enjoy. But you can get a cheap pair, and you should get 10 by 50. That's a good astronomical size. The 10 is the magnification, and in this case 42 is the aperture of each one of these lenses. And 10 by 50 is a typical size for astronomical binoculars, and you can see a lot with binoculars. If you get a 10 by 50 pair, they're reasonably light and your arms won't get too tired using them. That's a big consideration with binoculars. The way you use binoculars is you look at the sky to what you want to look at, and you put the binoculars up to your eyes without moving them, and then they should be in there. And since you have such a wide field of view, you can get quite a bit. I think a typical field of view for binoculars is about 5.7 degrees. These binoculars are specifically astronomy binoculars, and they're pretty big. They're 15 by 70, so they weigh quite a bit. So I got this special parallelogram which goes all the way straight up so you can observe the zenith. If you loosen that, and you can move it like this, and it stays in the position, which makes it very comfortable to look through, although it's kind of a hefty tripod. But it's a nice thing, but I'm not recommending it, but it is a nice thing to have. But definitely start off with your unaided eye, and then go to binoculars. And then if you're still interested in becoming an amateur astronomer, or hopefully you're like me and you fell in love with it, then you can think about a telescope. And we'll talk about that in the next chapter. But in conclusion, I would like to say that there is a huge difference between what you can see with a telescope and what you see in those fancy pictures on the internet that people took with their cameras. Some very expensive cameras, and some with images that took hours and hours to take. You are not going to see anything like that, I'm sorry. Even here in my Bortle 3 site with a nice 10-inch Dobsonian telescope with a 3-time Barlow, it was only then that I could see the spiral arms of the Whirlpool Galaxy. And if you look at people's pictures of it, it looks like the spirals are apparent very easily. No, they're not. And so you have to have realistic expectations, because it's going to be dependent on your site and whether there's light pollution, how well you see, what kind of equipment you have. But even the fanciest equipment on Earth, you're never going to see anything close to what the Hubble Space Telescope images or Astro Backyards images or astronomy picture of the day. No, not going to happen. Even the great Orion Nebula, which is fantastic to see in the night sky, is just going to look like, to me, kind of a grayish, bluish haze that is shaped like a bat. It is beautiful. I'm not taking anything away from it. You'll faint the first time you see it, but it's not going to be like those photographs. So just get that out of your mind right now. And with that, I'll conclude Chapter 2 of Tsula's Complete Video Guide to Becoming an Amateur Astronomer. So long till next time, I hope you have access to dark skies and that there will always be dark skies forever. Tsula signing off.